Hi everyone, my name is Huimin Zeng. I'm from Northeastern University. I'm really happy today to find a group of people with similar research topics through this challenge. So now let me introduce our solutions adopted in this challenge. Our team is called Maqic, and we aim to achieve an efficient video quality enhancement pipeline for the conference scenarios, which especially requires real-time enhancement. And also, by analyzing the dataset, we observe that the videos need enhancement from multiple aspects, for example, illumination, color tone, noise, compression, artifacts. For the noise and compression artifacts, the reason is actually quite complicated. For example, the noise may come from the low-light scenarios, which contains Gaussian noise or Poisson noise. And for the compression artifacts, the artifacts depends on the compression levels of current videos, which we have a paper this year to specifically analyze this problem. But based on the above analysis, we don't aim to solve all these degradations at one time. And instead, we aim to solve the most obvious problem. For example, the illumination and color tones, which simplifies the whole problem into a retouching task. And we finally adopt the lookup tables for this task. The typical lookup table solution, or we say the LUT solution, provides only the LUT-based pixel value transfer to accelerate the tone mapping process. But for the conference scenarios, we should especially pay attention to the portrait region, which means our retouching should be twofold. First of all, the retouching should be operated for both the background and the foreground. And the second, our retouching focus should highlight the human region instead of the background. And we notice that there is an existing work that can well address these challenges. So given the low quality input frame, the adopted method adaptively performs the fusion of multiple lookup tables and composes the 3D lookup table, which then performs tone mapping to obtain the visually satisfying results for each frame. But during training, we actually noticed that lookup table basically perform the tone mapping task, but different degradations will lead to the unstable training. Therefore, we adopt a stage-wise training strategy. In the first stage, we use the high-quality 5K dataset, and we only perform the tone mapping task. And in the second stage, we fine-tune the obtained lookup tables to adapt to the conference scenarios. For the results, our method can actually achieve a real-time tone mapping even with the CPU. But for the subjective results, since we just solve the illumination and color tones, the performance is not that convincing, which may also caused by the reason that we just adopt part of the dataset to fine-tune, and we didn't consider the temporal information, which leads to potential flicker when playing the videos. And due to the limited time, we couldn't solve all the challenges at one time, but we do have some other designs to improve our method, and our team just summarized them into specific papers, and you guys are welcome to find the papers here.